Hi everyone, we're going to be taking a look at our new unit in this first video. Our new unit is Unit 4, Chapter 2, and we're looking at the properties of angles that are formed when we have parallel lines, when we have triangles, when we have other polygons. And so we're starting with Section 1, where we're just exploring parallel lines. Now, along with taking a look at some of the different types of angles that are formed when we have parallel lines, we're also going to be going through just a quick review of some of the vocabulary terms that we have when we start to work in geometry. But some of the new vocabulary that you'll need to watch out for would be transversal, interior angles, exterior angles, and corresponding angles. Each one of these would be important for you to catch and make sure that you make notes about what they actually mean so that when we talk about them in the classes which come later, you are familiar with what they actually mean. So, first of all, let's check to see what you remember from the years of picking up different terms in geometry. So, can you name the following angles? Take a moment, pause the video, and see if you can write the names of the following angles. You'll notice that we're focusing on the size of the angles themselves, and so they each have a different name. First one is called an acute angle, and that's because it is smaller than 90 degrees. The next one is a right angle because it is equal to 90 degrees. The next one is called a reflex angle, and that's because it is greater than 180 and smaller than, of course, 360, but reflex angle is sort of an unusual one, so make sure you take note of that. The next one is called the obtuse angle. That's greater than 90, but less than 180. And the last one is a straight angle equal to 180. Now, the next couple of angles are highlighting how these two angles, this one right here, which is BXC and CXD, how together they form a right angle or they're equal to 90 degrees. These are called complementary angles. Please note that complementary angles do not have to actually be physically side by side and forming a right angle, as in this case. They can simply be one angle over here and another angle over here that when if you were to put them together, they would equal 90 degrees. We say that we're complementary regardless of whether they are geometrically beside each other or not. The next two, so angle AXD and the angle DXC, when we put them together, they form 180 degrees. And so they are called supplementary angles. There are different ways of remembering it. I like to think of it as they're an alphabetical order. So C comes before S. C is smaller than S. Some people think of S as a straight angle. Whatever it is that you use, you've got to be able to keep it straight. This one is just a quick picture to show you something we call angles at a point, meaning that all of these angles are gathered around one central point, and we know that all of them add up to 360. Now, these angles that are opposite one another, we actually call them opposite angles, and sometimes they'll be known as vertically opposite. Now, don't let that confuse you. I mean, these are vertically opposite. These guys look more like they're horizontally opposite. We don't make a distinction between that. So they're simply called vertically opposite angles, or sometimes just opposite angles. And what we know about opposite angles is that they are equal to one another. Next, we want to take a look at some triangles and see if you can think of or remember their names. So pause the video once again and see if you can write down the names of each one of these triangles. The first one, which is marked as having equal sides and equal angles, is what we call equilateral. Equilateral literally means equal sides. And if we were to be focusing on their angles, we could say that it was an equiangular triangle. We tend to stick to equilateral, but don't be surprised or confused if someone says it's equiangular. The next one has a distinctive point of having a 90-degree angle. We call that a right triangle. The next one has two equal sides. We call that an isosceles triangle. The next one is clearly marked as three different sides and three different angles. We call that scalene triangle. The next one we see the angles are marked as being smaller than 90, so we call it an acute triangle. And lastly, this one has a distinctive feature of having an angle that's greater than 90 degrees. So we call this one an obtuse triangle. Okay, lastly, we're going to take a look at some quadrilaterals that we need to be familiar with. These ones are written in a curious form, so I would encourage you to draw the similar diagram and put a label underneath them. Pause the video and make sure that you understand what they are. The first one is simply a random quadrilateral. Each side is completely different. We just call that a general quadrilateral. The next one, with one set of sides that are parallel and a second set of sides that are parallel, we call the parallelogram. This one, where we have only one set of sides that are parallel, we call the trapezoid. Under the parallelogram, we've got quite a few different ones. Remember, all of these that you see underneath are all parallelograms, but there's something also unique about them that gives them a different name. The one on the side has a parallelogram, definitely, but they happen to be the same length each side. We call this a rhombus. Then a parallelogram that has all four corners of a 90-degree angle, we call a rectangle. And lastly, when all the sides are equal and all the angles are 90 degrees, we call it a square. The good beauty of this diagram is it helps you distinguish with statements that we often like to make, and that is, are all rectangles parallelograms? Yes. But are all parallelograms rectangles? No, we also have a rhombus and a square. So this kind of a diagram can help you with that sort of statement to kind of file and order things. So it's a good one to remember. Now we're going to take a look at the different names for angles that are formed by lines that are intersecting. First of all, we need to know what a transversal is. A transversal is a line, you can see him in red, that crosses two or more other lines at distinct points. And what this transversal does is it makes an intersection right here with four different angles and another one down here with four more angles. So we have a transversal. Now, we have different types of angles that are formed when a transversal intersects two parallel lines. In fact, we use these names even if the lines are not parallel, but we're going to focus on parallel right now, just to keep it a little bit simplified. So first of all, I have a transversal actually crossing two parallel lines, and I'm focusing on the angles that seem to be squished in between the lines. We call these guys the interior angles. A, B, C, and D are all interior angles because they're in between those parallel lines. Now, interior angles that are on the same side of a transversal are called co-interior or consecutive interior angles. So A and D are on the same side of the transversal. We call them co-interior or consecutive interior. And B and C are also a set of co-interior or consecutive interior. Interior angles on opposite sides of the transversal are called alternate interior angles. So when we look at these guys, we're talking about A and C and B and D. I think many of you have referred to these ones as the Z angles. Okay, the next ones that we're looking at, we can see now that the angles are outside of our parallel line, so we call them the exterior angles. A or E, F, H, and G are all exterior angles. Now, exterior angles on the opposite sides of a transversal, sorry, I can't talk today, are called alternate exterior angles. So E and G are alternate exterior. F and H are alternate exterior angles. The last set are these guys. Now, what we want to see is that this is an intersection, and this angle is the bottom right. This is a second intersection, and this angle is the bottom right. These guys are said to be in the same position, and we call these guys the corresponding angles. And as you could see from my diagram, actually, there are lots of corresponding angles. We could say this one corresponds to that one, this one to that one, and finally this one to that one. We'll be looking at a question like that in the next example. But first of all, before we leave it, the relationship of corresponding angles is that they are actually equal to one another. Sorry about that, guys. I'll just turn it off for now. A is equal to E, B is equal to F, C is equal to G, and D is equal to H. Now, just a warning for you that those relationships for the corresponding angles will only work when the lines are parallel. If a transversal intersects a pair of non-parallel lines, they are not actually equal. And that will help us when we do a little bit of some proof, like a very simple proof writing later on. Okay? So transversals, when they're no longer parallel, these guys are no longer equal. We still call them corresponding angles, but they're not equal. Okay, so the first exercise I've given to you is a very simple one. Simply name the pairs of corresponding angles. Stop the video and give it a try on your own. And hopefully you've named that 1 and 5 are a pair, 2 and 6, 4 and 8, 3 and 7. Now, here's a little bit more, a question that involves just a little bit more reasoning to it. What they're doing is they give you an initial angle, and then they want you to find three more. So you're going to find those three angles, but you're also going to give the reason for your answer. So put another slide in here to kind of help me out with that. First of all, what they did, and I guess I'll go back one more time, is that they told us that angle APH, so the angle right here in the corner is 75. That's where we have to begin. So I've actually put that on my diagram. Now the next one they want me to find is BPG. And it is clear that BPG will be also equal to 75. The reason being that it is a vertically opposite angle, and vertically opposite angles are equal. The next one they asked me to find is BPH. So this one right in the corner. And so this one, if I look at it, is right beside these two. He's supplementary. So he's going to be 105. And the reason I would give is that supplementary angles are equal to 180. The last one they want is CQH, so the one down in the bottom corner, which happens to correspond to the one that we see up above. And so we know that it will be 75 degrees, and the reason is that corresponding angles are equal. Last type of question you're going to see, and this one pops up when you do the examples from your textbook, is they want you to tell them whether or not these lines are parallel. And remember, you're going to know they're parallel if the corresponding angles are equal. So these two angles are corresponding angles, but they're not equal. One is 57, one is 58. So we would say that AB is not parallel to CD. Now this one takes a little bit of work. I've got an angle right here in the corner. Now I do know that the angle across from it, the vertically opposite angle, would be 113. And this one corresponds to this one. And since they're both 113, then I could say, yeah, my line AB is parallel to my line CD. And that one would have a couple of steps to it. When it comes to trying to make sure that you write this out correctly, I would highly recommend that you check my solutions that I've given to you online so that you can check to see the format that is a good one for you to use to answer questions like this one. But there you have it. We've reviewed some geometric vocabulary terms, and we've explored the names of some angles formed by parallel lines. Your homework is one question from the textbook and then two worksheets. I have already posted those in our classroom, Google Classroom site so that you can see them. And good luck with your work. Have a good weekend, everyone.